All right, hey everybody. As you can see, I'm not here today, but you should have you're on your laptops right now like the sub told you to do. You're going to need to take out your packets that we're working with right now for our quarter 3 final review. What you guys should have done for homework was finished pages 3 and 4, and then you also should have pages 8 and 10 done. So what we're going to do is the following. I'm going to have you guys work on the warm-up questions right now on the first slide. You're going to work on questions 1 through 4, and then you're going to hit pause while you're working, and then when you're done, you're going to move on to slide 2 to check. So right now, whenever you're ready to get started, you can hit pause, and you're going to work on the first slide, work on your warm-up questions, and only when you're done, you're going to go to slide 2. All right, welcome back. So now that means you're done with your warm-up, so now you should be on slide 2 checking. Here are the responses. Notice in number 1, if we're going to triple the radius, then instead of having 3 squared in the formula, now we're going to have 9 squared in the formula. When we do that, the number increases by a factor of 9, so that's why the answer is B. I'm going to move over to question number 3. Notice the first box is bigger, and since we're going from a bigger box to a smaller box, that's a reduction if we were talking about a dilation. So because we're getting smaller, the scale factor should be less than 1, and since we're dividing by 4, the scale factor is 1/4. Now for number 2, if the rectangle is dilated by a scale factor of 3, that means it's going to be getting bigger, it's going to be an enlargement. So if side BC is currently 5 units long, B prime C prime will simply be times 3, 15. That is not a tricky question, it's pretty simple. Now the very last one, we have to go back to this box 1, box 2 thing. Notice if box 1 is bigger and box 2 is smaller, what we should be able to narrow down is that box 2 here should be smaller. Box 2 should be smaller. So I can go ahead and get rid of them thinking box 2 should be bigger, nope. And right here, box 2 being bigger, nope. Now we just got to figure out how many times smaller it is. And if you actually go through and calculate volume, length times width times height here, and then length times width times height, you can get the two volumes and divide and actually see that the second box is smaller by a value of 64 times. So that's why the right answer is D. It's not B, even though the scale factor is 1/4. And the reason why is if you divide by 4 here, and then divide by 4 here, and then divide by 4 here, you're dividing by 4 times 4 times 4, which means you're dividing by 64, so the box is 64 times smaller. All right, at this point, I'm going to have you pause again so that you can get to your packet, and on the next slides, what we're going to be doing is we're going to be checking our homework. So go to your packet right now, turn to page 3, hit pause if you need to, and then when you're ready, you can hit play, and we're going to go over the homework. All right, welcome back. Now you should have your homework out. So for question number 1, which is the best name for a quadrilateral, that's a parallelogram. Down to question 2, which is most likely not a rectangle. Y'all, this is pretty simple. Now B, it looks a little maybe like you couldn't catch that those were right angles, but they are. C is a parallelogram, there's no right angles, that's why that one's not a rectangle. All right, now for number 3, which quadrilateral has 2 pairs of congruent parallel right angles? So that one's going to be C because of the congruent part. It's got to be a square. All right, this is pretty simple. Number 4, you should have gotten D, 1 pair of parallel sides, is a trapezoid. For number 5, I did draw the little diagram off to the side in case you weren't sure, but a square is definitely not a type of trapezoid. So A, C, and D all suggest that it's a type of trapezoid, so it's got to be B. And right here in the chart, you could see that if you told a rectangle to get it together, and you were to tell a rhombus to straighten up, they would form this square. So the square is a type of rectangle and rhombus. All right, now for number 6, which quadrilateral is not a parallelogram? That's going to be D. It's kind of like saying which rational numbers, or which of the following are not rational, and you would pick D, irrational. And for number 7, which statement is not true? Well, definitely all squares are a rhombus. Look up here. To be a square, yes, you are a rhombus. So that one's good to go. Every square is a rectangle. Yep, to be a square, first you're a rectangle, so we're good to go with that one. Now, does every quadrilateral has to have a 90-degree angle? No. Look at the picture I've got. There's 4 sides. It's a quadrilateral, but there's no right angle. So that does not have to be true every time. But for D, yes, to be a quadrilateral, you have to have 4 sides. All right, cool. Now let's flip over. Whoops, I'm going to scroll down, sorry. All right, here, flipping over to number 8. Which figure below is a rhombus? That one is B. Yes, it's a square, but all squares are considered rhombi first. So technically, yes, it's a square. The best name is square, but it is a rhombus along the way. If you picked C because you saw the slant part and you thought that that's what was going to make it a rhombus, notice all the sides aren't equal, so it's not C. For number 9, as long as you've drawn some sort of rectangle, you're good to go. And down here to classify it, make sure you have all of these names. I bet you probably just put rectangle, but first it's a polygon. Then it's a polygon with 4 sides, so it's a quadrilateral. It's the kind of quadrilateral where opposite sides are parallel, so it's a parallelogram. And then the part where all of the 4 angles are right makes it a rectangle. So you definitely want to notice all of these still apply, but the rectangle is the best name. However, you should have everything here listed. All right, so now what we're going to do is have you flip over in your packets to pages 8, and then we'll go over 10. I'm not going to spend a whole lot of time talking about how to do these problems because it's just formulas, and I'm going to let you just scroll through right now. I'm just kind of slowly scrolling through so you can check your work. In the first one, it's square feet, so that's area. There's lots of ways to break it up, but I chose to just find a big rectangular area and subtract out a small rectangle. So for that one, we should get the second one, G, 3,400 square feet. Because it says square feet, that's how you know you have an area question. Number 5, it tells you there's a perimeter problem. If the shape up top has 8 sides, it's an octagon. So I just drew 8 blanks to make sure I had all my sides, and I filled them in. When I did that, I did notice I had one missing side here and here. Luckily, this one was given as the 20, so this was the only number we really needed to find. And if you're unsure how I got it, 70 up top, subtract 20 would be 50, and subtract 10 more would be 40. Oh, wait. Or sorry, 70 here minus this 30 means this has to be 40. That's what I was trying to say. So that's how I got that for the 40 right there. All right, and down here, you're just plugging in numbers and recognizing the formula. 1 is A. And unfortunately for number 2, none of those answers are actually correct. We've had this problem with this worksheet in the past. So if you were stressed out thinking you were doing something wrong, you didn't do anything wrong. The correct answer for volume is 1,155.52. It's cubic centimeters, just so you know. All right. So if you have any questions with that, you can just ask me on Monday when I get back. Now let's flip over to the last thing you guys had to do for homework, which was page 10. For the first one, very simple problem. It's just that there's no picture there, so you have to imagine what the picture would look like for volume there. Number 4, you have a top and a bottom of a soup can, so those are the 2 circles, and the label of the soup can would be that rectangle. Now number 5 is the only one on the homework for real I was worried about. I'm betting for number 5, a lot of you picked C because you plugged in the formula for surface area of a cylinder. However, in the formula for surface area of a cylinder, there is a 2 right here because we're having the area of 2 circles included, the top and the bottom. However, we're not going to multiply pi r squared by 2 because we don't want to cover the top because she wants to leave the top open for pencils. So what we're going to do is we are not going to include that 2, which means if you picked C, your answer is too big by one of these circles. So if you subtract about 86 from your answer, meaning you subtract that top part, what you might have included, you'll get D. And the way you can just use the formula here to get D is just pi r squared would be covering up the circular bottom, and then this 2 pi RH is going to be covering up the rest of that cylinder, the curvy part. All right, now to number 6, you're just plugging in, and same thing for number 7, you're just picking out which numbers would get plugged into the formula. So at this point, I'm going to ask you to pause and put your homework away, and if you're done checking over your homework, what the sub should have told you to do is to come and get a copy. Actually, no, you don't need to get a copy. Sorry, I'm just kidding. You guys now can turn to the page in your packet. You're going to turn to page 13 in your packet, all right? So we're at 13 in our packets. Sorry, you didn't really need to pause then, I guess, if you can just flow right on with me. So what we're going to do now is I'm going to go over similar figures with you for a little bit. In parts of the video, I'm going to just tell you to pause so that you can work, and then when you hit play, you can check your work. And this is just going to be what we do for the rest of class today. If you want to jump ahead at any point, that is okay, and then kind of just fast forward in the video to check. But honestly, guys, this is the part where Mr. Parker was teaching, and this lesson right here, this page is super important. Give me about 3 to 5 minutes in this video to go over the front, and the back is when you're going to have time to just prove to me that you know how to do everything. So bear with me a little bit longer. I love you guys. Hi, how are you? Have you missed me today? No? Okay, cool. I bet not. All right, let me talk to you guys about how this similar figure stuff breaks down and how to write that similarity statement that I talked about the other day in class. So what we've got here is two similar figures. I've told you that they're similar, so we can assume that. And I've already highlighted the colors to match up. What this shape is done is it's been turned, so they're not oriented the same way. So if I turn this now, that'll help you see a little bit better the sides that match up. So now we can see that A corresponds to angle D. So you're going to fill this in on your notes along with me now. You're filling this in with me. Angle B down here corresponds to angle E. And angle C corresponds to angle F. So corresponds here is basically just like a fancy word for matches up with or is in the same spot in the other shape. So when we've done that, now that we've matched up our angles, we can also match up our sides and say, okay, so from side A to B, so going from A to B down here, that would be like on this shape going from D to E. So D, E, and the line above just measures out the fact that we have a segment. Now I'm going to go over here for a split second and turn this back to say, okay, you can still think about it when the shape is turned. A to B goes from yellow to green, so we can still go from yellow to green here and see that it would be side DE. So now BC from B to C would be blue and green, but we're going from green to blue, B to C, so we're going to go from green to blue, E to F. Yes, it matters with the letters. Now A to C means we're going from yellow down to blue. So yellow to blue would be D, F. What we can now do is build our similarity statement. If we know A and D go together, so we can say if angle A, and then we're going to have angle D. B then E, B, E, and now angles C and F. So what we can say is triangle A, B, C is similar to triangle D, E, F. And what that means here is that we can see AB would be side DE. That's going to be that part right here. So now you can use the similarity statement to answer these kinds of questions down here. So BC right there would be EF, easy enough. And from A to C would be D to F, which is the last one. So now what I want you guys to do is I want you guys to pause, and I want you to try to do the next one on your own. You can see the first two, the answers are already filled in for you, but I want you to pause right now and try to fill in the corresponding angles and the corresponding sides in the next section. So hit pause right now and do the next 1 through 8. All right, welcome back. So here are your answers here. Those are the angles that match up. K is down here with H. And to help you see it, if you need to turn, there you go. There it is. All right, so K and G. It's not H. You might have thought it was H, but it's G. All right, so now we can take a look at the other ones. L, H. So there's L and H. Now down here, let's just go ahead and look at GJ. I can go ahead and fill these in for you guys. So from G to J would be K to N. IJ, so from I up to J, M up to N. mn, and hi, so h over to I, is L over to m. The order of the letters does matter. All right, now down here, what we're going to do is figure out whether or not each pair of polygons is similar. This should be a review for you. Right now, because these shapes aren't turned the same way, I'm going to turn this one the same way to help you see it a little bit better for my matching sides. Here, if this is green, that's green, which means this is green. In here, if this is blue, that means this is blue, which means this is blue. Whoops. So now I'm going to get rid of this. And now we can see which sides match up. And all I have to do is draw a proportion. So we're going to go here from a smaller shape to a bigger shape. As we can see, it's 6 to 24. So 6 to 24. And then 8 to 36. So we went from the smaller shape to the bigger shape. And right here, what we can do is we can catch that 6 times 4 would be 24, but 8 times 4 would be 32, and not 36. So because they don't have the same scale factor, we can determine that they're not going to be similar because they're not proportional. Now, if I get my calculator out, the other thing that I can do is just cross multiply and see that 6 times 36 is 216. So 8 times 24, though, is not the same value. So when we cross multiply, they're not the same, which once again proves that no, these are not similar. Now I want you to pause and check out number 2 on your own. When you're ready, you can come back. All right, welcome back. Just to make sure you're okay with this, if you turn this shape, we can see that 8 gets cut in half to be 4. 14 gets cut in half to be 7, and 20 does get cut in half to be 10. So yes, these are similar. All right. Now at this point, everything else on the back is review. So I do want you to go ahead in your packet right now and turn to the back. Go ahead and turn to the back. You should be on page 14 right now in your packet. Take a look at these questions. Remember mindfulness. Just take a look at them and see if you know how to do this stuff. It is okay in your work here when determining the missing side here, if you just determine a scale factor, that's cool. Make sure you tell me what the scale factor is. If you set up your proportions, make sure you set up the verbal model telling me we're going from a small shape to a big shape or a big shape to a small shape. And then you can just cross multiply and divide and tell me the missing value. So right now, you're going to take about 3 to 4 minutes to try to work right now on these questions. If it takes a little bit longer than that, that's okay. But hit pause, and whenever you're ready, you can hit play, and I'll have the next slides ready with your work shown. Do not just copy my answers. There is no point in doing that. Prove to yourself that you can do this. Make sure you're confident and ready for your quarterfinal. Hit pause and go. All right, welcome back. So here we are. Here are your answers. For the first one, you should get x is 18. Because we can see a scale factor. Depending on how you look at it, depending on how you answer it, you could tell me the scale factor is 1/2 or 2, depending on how you justify it. You could say if I'm going from the big shape to the small shape, the scale factor is 1/2. But if I'm going from the small shape to the big shape, the scale factor is 2. Either way, half of 10 is 5. So 9, half of that, it is half of 18. All right, for number 2, same thing. You can recognize a scale factor or cross multiply, but for that one, we're going to get x is 15 inches. For number 3, that one is going to be x is 6 feet. And for the last one, here is the deal. I gave you both matching sides for the pink and the blue. Some of you wanted to use 6 over 3.6 and use the pink stuff. That's fine. Some of you wanted to use the 6.5 and the 3.9, and that's fine. You do not have to do both proportions to get the answer. You can use either the pink side and then the yellow, or start with the blue side and then use the yellow. It doesn't matter. In both situations, we're going to get that x has to be a 2.5. All right, So now that we're done with our classwork, and you've done your warm-up and everything, here's your homework for the weekend. What I want you to do for the weekend is I want you to, in your packets, flip with me to make sure you're okay seeing everything. You're going to do a little bit more measurement practice on pages 11 and 12. It's front and back. Yes, you can use your formula sheet. Yes, you can use a calculator. And then I want us to practice some of the stuff with shapes that we've been doing and similar figures. So I want you guys to do pages 15 and 16. That should not take too long. So for homework this weekend, you have 4 pages total. 11 and 12, front and back, and then 15 and 16, front and back. If you have extra time in class right now, you may get started on the packet. Please log off with your computer and just go return it. The sub knows that right now you guys have been watching a video and you must be done with the video at this point, and you should be working on your homework. The sub might come around to check to make sure you did the classwork if you're working on your homework right now. And this is a very, very important thing that I'm going to say, so I hope you're listening to the video all the way to the very end here. I am going to be checking next week for the following pages to be done in your packet. We have done, so if you want to go to the beginning of your packet and make sure you're okay with me, this is super important. We did pages 1 and 2 in class already. You should have done 3 and 4 for homework, plus I just went over it in this video, so it should be complete. We also did pages 5 and 6 in class. Now, depending on which class you're in, 7 is still open and 9 is still open, so maybe 7 and 9 depends. But everybody should have 8 and 10 done because of the homework. Over the weekend, you should be doing pages 11 and 12. Today we did 13 and 14, and you're also doing pages 15 and 16 for homework. So in your packet, when you get back next week, the only things that should not be done would be pages 17 through 22. We haven't reviewed transformations yet. And then maybe, depending on which class you're in, you might not have pages 7 and 9 done. It just depends. So pretty much the majority of the packet should be done on Monday when you get back, and I will be checking that everything is done so far. This packet is super important, folks, and I need you reviewing. So for your homework this weekend, good luck. Pages 11, 12, 15, and 16. And I will see you guys on Monday to talk about transformations when we get back. Bye.